Hello friends, so today we are going to continue our previous lecture that is related to the introduction of composite materials. Now in the previous lecture that we have seen something about what is the definition of the composite, then what are the natural and synthetic composite, then some sort of that advantages, disadvantages of the composites and the classification of the composite material. Now in today's lecture, the contents are we need to be understand what are the characteristics of fiber, then the characteristics of the fibers, that is reinforced composites, then fiber orientation, then types of the fibers. In that types of the fibers that we are going to see the glass fiber, carbon fiber, armide fiber in detail, and we will see the cost comparisons of all these fibers. And in the last part of this content, that is the application of the composite materials. So what are the first of all characteristics of the fiber? Basically the characteristics of the fiber are mostly depends on the length of the fiber as well as the diameter of the fiber. So basically the whatever may be the ratio of this length as well as that diameter, it's normally called as an aspect ratio for that particular fiber. And this particular aspect ratio, that is we are measuring this aspect ratio by considering the length to the diameter ratio, where L is the length of the fibers and D is the diameter of that particular fiber. So basically the strength increases when the aspect ratio is large. Means what? Whatever may be the strength of the fiber is there. So when the strength of the fiber will be increased, that when the length of this particular fibers, that should be a larger one, or we can be able to say in simple manner, if the aspect ratio is large, then that particular strength of that particular fiber is quite high. Then whatever may be the diameter is there for the typical fibers, so those diameters might have vary from 10 mm to generally 150 mm. So basically whatever may the failure of that fiber is concerned, so the fiber are fractured because of that surface impression. So this is quite a natural failure of that fiber is concerned. Then here that one graph that is related to the glass fiber, it has been plotted. So here you can be able to understand. So on the x-axis there is the length of that particular fiber. So this length is measured in terms of inches, and then on the y-axis you can be able to see the tensile strength of that particular fiber. So basically whatever may be the strength of this particular composite, that will be increases when the fiber length will be increases. So along with that particular length, here you can be able to see whatever may be the strength of that particular glass fiber, that is going to be increased. Then here this particular, we can be able to say graph will be gives you the idea about the fiber angle orientation. Okay, so here the fibers are bounded at the 0-degree inclination, and here the fibers are bounded at 90-degree inclination. So these are the some concern points related to the particular strength of that fibers are there. So here we can be able to see that if the fibers are oriented in the 0-degree inclination, so 0-degree inclination in the sense what? So the fibers are wounded along that particular whatever maybe the loading conditions are there. If you are applying the load on this direction, and if the fibers are also wounded in this same direction, so that particular direction is called as a 0-degree inclination. And here you can be able to observe that, so whatever maybe its strength is there, so that strength is quite high when we are wounding the angle or keeping that particular fiber angle at the 0-degree. Now here you can be able to see that if we are varying that particular fiber angle from 0 to 30-degree, so basically whatever may be the strength of that particular fiber, that will be reduces. So similarly for 45-degree, 60-degree and 90-degree. So the fiber, when we are wounding in the longitudinal direction, that is giving a quite high strain as far as that loading conditions are concerned. That is the tensile strain. We are talking about the tensile strain. So sometimes if we are wounding the fiber angle with the 45-degree inclination, we are getting the shear strength also good, but that will be the case to case study for the different kind of that fibers are there. Now here for the 90-degree, we are getting very lowest strength for that particular fiber. So this is the in general study related to the glass fiber is concerned. Now you should be able to understand what is the fiber angle orientation. Now here you can be able to see the two kind of that cases over here. In the first picture, you can be able to see whatever maybe the fibers are there. So all those fibers are wounded in the same kind of that direction. So this particular direction we are considering this is as a 0-degree inclination, means we are just whatever maybe the load is there. So that load is applied in the same direction. And in the second picture, that is at the right side, you can be able to see that the first plate, that fiber angle is at 0-degree. But in the second plate, the fiber angles are changed, that is at the 90-degree. Then in the third plate, again it is at the 45-degree. In the fourth plate, it is 45, but it is in the reverse direction. So that's why it is plus minus 45 kind of that thing we have written over here. And again in the next plate, same kind of that, and we have just made the symmetrical impression at the bottom side. Now in the first case, this particular fibers are called as a unidirectional fiber. Now unidirectional in the sense it is not like that. If you are wounding the angle or keeping the angle only at the 0-degree, then only it is called as a unidirectional. No, it is not like that. If you are wounding all the fibers in the 90-degree, it is also the unidirectional, means direction is not going to be unchanged. If you are keeping all those angles at the 45-degree, it is also called as a unidirectional fibers. Okay, so these are the in the last lecture already that we have seen that this particular thing or this particular plate, single plate, it is called as a lamina. Okay, so these all are the laminas, and when we are bounding all those laminas together, this particular form the laminate. So this is the difference in the lamina and laminates. Okay. And in the second case, this particularly called as a cross-ply quasi-isotropic fibers. So these are the arrangements. So what is the meaning of quasi-isotropic and what is the meaning of unidirectional? I think it is gets clear to you. Now we will talk about some sort of that types of the fibers are concerned. So normally there are whatever the fibers are there. So these fibers are generally classified into the two types. So one's that particularly coming under the polymer matrix composites. So in the polymer matrix composite, these are the three important categories of the fibers are there. That is the glass fiber, then the carbon fiber, then aramide fiber. And in the metal matrix composites are concerned, again the boron fiber and carbon fiber. So basically these are the general categorizations of the fibers are concerned. Definitely apart from this, again many more fibers are there. But in the last lecture that we have seen about some natural fibers as well as some man-made synthetic fibers likewise. But these are the fibers where now we are using such a fibers in the composite structure application, and we are just forming the fiber reinforced composite by using such kind of that fibers, and these are the widely used in the applications. Now we will talk about some sort of that about the glass fiber. Now what is the meaning of glass fiber or how it is looking like? So this particular part we will cover over here. So basically the glass fibers in many more application you have seen that the glass fibers are mostly used. Now what is the reason behind it? The glass fibers are very widely used because it is having a very low cost as far as that cost is concerned. So that is giving the majority of the time that particular fiber reinforcement is giving the strength quite better than that of metals. But whatever maybe the glass fiber is there inside that particular composite structure, so that glass fiber is having very lower cost in comparison of the other fibers. So that's why this is widely used in the nature. Now basically these are the some sort of that varieties of the glass fibers are there. So those generally glass fibers, are considered as an E glass, S glass, C glass, M glass likewise. So might be you have seen some sort of that when you are just going to purchase some sort of that glass fiber. Sometimes you have to make the some confusion which glass fibers you need to be purchased over there, because there are the variety of the types are available, that is like that E glass, S glass, M glass likewise. And those particular glass fibers, what is the meaning of this E, C or S kind of that things? So E stands for the electric. So if that particular fiber basically it is having the low electric conductivity, then S, that will be stands for its strength, and such a glass fiber is having the very high kind of that strength. Then C stands for the chemical. Okay, so those glass fibers are having very high kind of that chemical durability. So in the previous lecture also we have seen that the particular fibers might have gets affected because of some sort of that chemical agents or solvents, and those particular chemical reactions are badly affecting the particular strengths of that particular fiber. So C means if the chemical application kind of that thing is there, if you are using that particular composite structure where the chemical reactions are taking place, then normally C glass kind of that fibers are generally preferred over there because it is having very high kind of that chemical durability. Then M stands for the modulus, so that is providing the very high kind of that stiffness to that particular composite structure. Now related to the carbon fibers, nowadays in many more space application also you have seen that the carbon fiber is widely used. Now why basically the carbon fibers are not using widely? Because it is having basically very high kind of that cost. So the strength, it is quite again very good than that of glass fiber, but ultimately again we need to be pay a higher cost. But nowadays those particular carbon fibers are also getting in the reduced price, and that's why it is again the preferred into that particular such kind of that applications. So generally it is almost having the 5 times stronger than that of steel, and it's whatever may be the weight, if we compare the weight, it is again the 1/5 weight as far as that steel is concerned. Means if suppose the steel is having 600 whatever may be the Newton per mm square kind of that tensile strength, then it is 5 times more than that of steel. Means normally we are getting the 3000 Newton per mm square kind of that strength and weight. If suppose the steel shaft is having of, or any steel application, if it is having the 1 kg weight, then within the 200 gram we can be able to manufacture such kind of that composite structure with the same kind of that strength. Then almost if we compare this particular thing with the aluminum, that carbon fibers, then it produces the 7 times it is stronger than that of aluminum, and whatever maybe its weight is there, so almost it is 2 times lighter in weight. Means if suppose the aluminum shaft is having 1 kg weight, then we can be able to produce the same structure with the help of carbon fibers in within the 500 gram. Okay, so likewise we can be able to compare the carbon fiber with this particular aluminum also. So these are the metals comparison. Actually we are comparing this particular fiber with the metal, and basically these particular fibers are exclusively used in the aerospace industries. So already I have mentioned this particular thing. Now the next fiber is the armite fiber. So basically the armite fibers are more and more common nowadays, and it is having very high kind of that specific strength among all these fibers. Also it is basically known for the very higher impact strength, and common form of this particular armite fiber is the Kevlar. Now Kevlar, that we are all are knowing that particular Kevlar fiber that is mostly preferred in some sort of that bulletproof jackets or some sort of that the application where high kind of that impact strength is required. So these kind of, this is the actually the glimpse of that particular armide fiber is concerned. Here in the previous case, here you can be able to see this is the carbon fiber which is looking little bit blackish in nature, and here the armide fiber, it is quite looking like some sort of that yellowish in nature. Okay. Now this is the cost comparison. If we'll compare the cost of all such a fibers, so basically those particular fiber, here the boron, it is almost available in $320. If we'll compare this particular boron with the carbon, so carbon is almost we are getting in the $30. The Kevlar fiber, it is we are getting in the $20. And if you compare all these fibers with the glass, almost the glass we are getting in the $3. So this is actually the generalized cost comparison. I'm not talking about some sort of that specific cost. This maybe gets varied in the market, but this is the very generalized comparison of the cost. So you will get the idea about how this particular fibers are having the effect of that particular cost. So if you are having very high kind of that specific application and where the boron is needed, then only we are preferring the boron because it is having very high kind of that cost. But if the structure is producing a same kind of the strength with the e-glass also, and the whatever maybe its application, if it is not having very kind of sensitive kind of that application, then we can be able to go with this e-glass fibers also. Okay. So here in this particular image, here you can be able to see some sort of that glimpses of the here you can be able to see the glass fibers, how the glass fibers are looking like. Here you can be able to see over here. So the glass fibers over here that we can be able to see, it is quite whitish in nature, and basically when we are just using such kind of that mats or woven fabrics, so we have to take care that we cannot be able to handle that glass fiber directly without any gloves, because that particular glass contains maybe gets penetrated in your hands, and later on that such kind of that itching kind of that thing maybe happen when you are going for that real application. Means when you are manufacturing with some sort of that hand layup methods, so those methods also we will see in the further part of this lectures. So if we are using the hand layup method, we cannot be able to use or handle such kind of that glass fibers directly with the hand. We have to use some sort of that gloves for the safety purpose. Then this is the glimpse of that particular carbon fiber. So carbon fiber are quite blackish in nature. Here you can be able to see that carbon fibers which is quite black in nature. So it is almost opposite to that particular glass fiber. Glass fiber are looking very whitish in nature, and carbon fibers are normally looking very blackish in nature. Okay, so these are the some mats of the carbon fiber as well as this glass fibers. Okay, now in the last part of this particular lecture, that is related to the applications. So what kind of that applications that composite material is having? So basically the composite material is widely used in the aerospace industries, where the weight part is very much vital over there, where we want to reduce the weight of the structures in the aerospace application or some sort of that satellites. So for that purpose, the light in weight kind of that material is required, and that's why the composite is more preferred over there than that of metals. Then in the nowadays in the automotive industries, normally when we are manufactured some sort of that sports car, or even nowadays in the EV cars also, the weight part is very much vital over there, and the reduction of the weight is quite important, and that's why in the such kind of that automotive industries also the composite material is preferred. Now the components in the sports or some sort of that structural elements in the civil for the strengthening of the beam and all such kind of that application, the composite is preferred over there. So we can be able to use some sort of that different fiber just to provide the strengthening of to that particular old beam structures. Okay, and last is the marine industries. So in the marine industries, basically whatever maybe the chemical reactions are happen on the metals, and that metal will be gets corrode because of all that, and that's why whatever may be this particular composite materials or fibers will be gives you a very great kind of that application for the marine industries. So these are the actually the contents of the today's lecture. I hope that you have very much cleared some sort of that basic things related to the composite material, and in the further lecture again we will just take the look related to how the composite materials are manufactured, what are the different methods to manufacture the composite and all. So thank you very much for the patience listening. Thank you.